Okay, hello students. Today I'm gonna solve problems from lesson number 6, practice problem. So the lesson 6 of unit 1 in algebra 2, the topic is representing sequence. Now sequence can be represented by the table, graph, and also with the equation. So let's see it straight away. What are the problems being asked, starting from 1. Okay, so this is the first problem. Uh, an arithmetic sequence A, so this is arithmetic sequence. When I say A means it is A of n, right? And starts with 2, 5. So if this is 2, 5, I'm gonna make a table just for understanding. Let's really get it. So we have starts with 2 and 5. So this is 2 and the first term is the 2 and the second term is the 5, right? And this is the step number and the name of the sequence is A. So I'm gonna write A of n, right? So this means n is 1, this is n is 2, and this is n is 3, and so on. So basically what is this means? That is a of 1 is 2. I'm just want to, even though you know, but I feel like I'm just trying to show one more time that a2, the second one is 5. And because it is arithmetic sequence, it has a rate of change. So you want to know what is the rate of change from 2 to 5. And clearly see, if you subtract 5 minus 2, and you get a common difference with the rate of change, which is 3, and it is plus 3. That means you're adding plus 3. So each time you add plus 3, and then you get 8, and you get the next one is plus 3. And so that's the sequence you get. Plus 3 is 14. Now, the question is write recursive definition. Now, what is recursive definition is, you can clearly see the A2, which you see this A2. The A2 basically is A2 is the previous is same as the A. This is the previous one, right? So this is 5. The 5 is 2 plus 3. So it is A of 1 plus 3, right? Now, if I want to know this third one, that's this one is A. This is A of 3, right? The third term. The number in the third position is 8. So A of 3 is is the A of the previous one 2 plus 3. So that's how you can clearly see going on. So the very first one, so A of 1 is 2, and then after that the first term is 2, and then after that any term or the number in any position is always 1 less. Let's see, this is 3. Can you see this is 2? So it's 1 less. If it is 2, it is 1 less. So it is the previous one and minus 1 and plus you're adding 3 plus 3. So this is how you're supposed to write recursive definition. But then remember, this works for n is 2, n is 3, n is 4, and so on. So that's why instead of writing all this, just write only one and say not only 2, but everything that is greater than 3, and you're done. So this is called a recursive definition of the arithmetic sequence. And if it was for geometric sequence, then you are not adding here, then you'll have to multiply the previous one. Use your definition to make a table of, and then we have already done. So this is the table we did. This is the 4, this is the 5, and it's asking us what is A of 6. So A of 6, you add another 3. So I'm just going to make 2 plus 5, 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, plus the 14 plus 3 is 17. So your answer for so this is the one, right? So A of the number in the sixth position is 17. So that's all it is. So hope that helped. Let's move to the second question. Okay, the second question is, instead of arithmetic sequence, it gives you geometric sequence, and the sequence name is G. So again, I'll make a table. So I want you to draw this so that you get an idea. And he wants us to first 5 terms in the sequence. So the name of the sequence is G of n. So this is step number 1, 2, and 3, and 4, and 5. So the very first 2 terms are given 1 and 3. And then because it is a geometric sequence, so what multiplies to the first number is clearly series 3, right? So 3 times 1 is 3. Then again you multiply 3 times 3 is 9. Again you multiply 3, you get 27. And again you multiply 3, you get 81. So if I want to graph this, the next question is, you are supposed to write the recursive definition. Now, what is the recursive definition is, remember this is A of 1, sorry, G of 1. This is G of 2. This one is G of 3. This one is G of 4. And this is G of 5. So all you're doing is, if I want to compare this G2, so how did we get G2? You multiplied 3 to the first one, G1, right? How did we get G3? Because you multiplied 3 to the previous one, G2. So from here to here, you multiply by 3, right? So each time you multiply by 3. So this is G of 1, right? And likewise, G of 4 is you're again multiplying 3 to the previous one. This is so each time this is actually 3 is, we can write it as 4 minus 1. This is, you can write it as uh, 3 minus 1. And that's why we say, okay, so the recursive definition is any term is 3 times the previous one, G of n minus 1. And that's it. And this is for n greater than equal to 2. But only thing you have to write down, okay, what is the first one is, it clearly says it is 1. And this is the recursive definition. They asked us one more question, is to graph this. So if you want to graph, then we'll have to make grid. We'll have to make mhm, we'll have to make a grid here. See? And again, 1, 2, 3, 4, and 5. Right? And then the maximum that I took is 80. So let's see if this was 80, and then I just make half is 40, and then 20, and then in between maybe 60. So when it was the first one starts with 1, maybe we don't know, it's very, this is 10 here. So somewhere here is 1. Then the second one was 3, somewhere here. Then it was 9, maybe here. Then it was 27, and this is 30, so a little below that. And 5 is 81. So this is how you get the graph. So this is n, and this is gn, and you're done. So that's how you're supposed to graph it. Let's move to the next one. So there is also a question asked how to find recursive definition to determine g of 30. Now to find g of 30, remember our g of 1 was 1, then g of 2 was 3, then g of 3 was 9, and g of 4 was 27, and so on. So if you want to find g of 30, we can use, instead of g of 1, we can consider this one, g of n. Look at this. So g of n, and because it's always going by 3, right? Say 3, so you can say 3 raised to n. And this takes care even when n equals, but instead of saying n equal, you're not going to use this, and you can say n equals 0, 1, 2, and you can get, because if you put 3 raised to 0, it is 1. If you put 3 raised to 2, it is 1, then it will be 3. If you put 3 raised to 2, it is 9, and that's how this formula works. And that's going to be also called n formula also. Or there is another way to write is, we will see in the next lesson, is g of n. If you don't want to use the n is 0, we can say, okay, the first number was 1 times and 3 raised to n minus 1. And here we'll say n is greater than equal to 1. So this also is correct, and this also is correct. But if we say n equals 0, then you just write 3 raised to n, and here it is 1 into 3 raised to n minus 1 also. Okay, let's move to the next one. So question number 4 is, this is question number 3. You're supposed to match it. So let's do it quickly. I want to, the question, match the following with one of the definitions is given to you. And note that the only part of the definition showing relationship between the current term and the previous. So you are given, looks like they gave you the recursive definition. I will go from here. So let's see what is this basically means. 1/3 the previous. So what multiplies to, so it's like if you want to make a table, that means you're multiplying by 1/3. So let's see, this multiply 1/3? So when you say 1/3, meaning it has to decrease. So this is increasing. So this is not the answer. This is 1/3. Is it 1/3 of 18? Looks like it is 6, right? Correct. Okay. Then 1/3 of 6 is 2. And 1/3 of 2 is 2. So this is correct. So this goes exactly the first one. So that takes care of the first one. And let's see the second one. Here you are taking, what does this mean? Your D is the rate of change is negative for it. Every time you are decreasing by 4. So you have to look up for whether sequence is decreasing. And you can see this one goes down by 4. So this connects straight away here because you are subtracting 4. So that's how it is. And the next one you multiply by 5. What does this mean? Each time any number in any position is always 5 times. And so this part is 5 times because if you multiply 3, so 3 times 5 is 15. Then again 15 times 5 is 75. And again times 5 is, and you get the answer. And the final one says, what does this basically means? This is any term is the previous, so you're adding the previous plus n minus 1. Now, what is this? Is the step number before. This is the step number before. Step number before. That means you can see here this number. Let's talk about this part. This 7 is nothing but the previous one 4, and also the 4 is the third position. See, so and that's why one less. So n minus 1 is it is third position, and 7 equals 4 plus 3. And this is how you can get. And you can see this 2 is 1 plus 1 position. This number, how you go from 2 to 4? It is the 2 and the second position number, which is 2. The 2. So hope that helps. Okay, question number 5 is saying, write first 5 terms of the sequence. So again, easy question just for practice. So what I given here is the recursive definition, right? So they give you the recursive definition or recursive formula, or it's also called the in the function notation. So they give you function notation. Okay, how to write? So if I want to write for this one, let's make a table out of this. Okay, so for every one, so we can make a table for each one of this and write only the terms, right? So we can write this way. And the first one will make a kind of, let's say this is, okay, here. So one, this is, no, this is A of n, this is B of n. Sorry, I made a mistake here. This should be step number. The first one is the step number 1, 2, 3, 4. So this will be A of n. This is B of n. This is C of n. D, the function is in dn, then F. No, there's no E. Okay. Now, I think I messed up again. This should be on the, this, okay. Let me go quickly on this. So there's a number line I missed, and I'm gonna make it here like this. So this is the n, and this is b, and okay, this is c, and I'm trying to write, and this is d of n, and this is f of n, right? Now, I want you to pause the video, and if you can figure it out yourself, that would be so nice. Okay, so this means the very first, look at the first part is all starts with 1. Every sequence starts with 1. So we'll have to put 1, 1, 1, 1, 1. And next is you see here that there's a growth rate. That means you're multiplying each time 3. That means I'm going to multiply here 3 times 1 is 3 times 3 times 3 is 9, 3 times 9 is 27, and that's how you do the next one. In this case, what are you doing is you're taking away. This means you're reducing by 2, so you're decreasing, so you're going down by 2. So 1 minus 2 will be minus 1. Again minus 2 will be minus 3. Again minus 2 will be minus 1, and so on. So you're decreasing by 2, and like that. The next one is there are two things happening. Not only you're multiplying the previous one by 2, at the same time you're adding 1. It means you're multiplying by 2. So you're multiplying by 2. and then also 2 times 1, that's multiplying by 2, and then adding 1. So 2 times 1, so you get 3 here. Now again, you're multiplying by 2, and then adding 1, which will be 7. You're multiplying by 2 and adding plus 1. So you'll get 2 times 10, 14, so it becomes 15. Again, multiply this by 2 and then add add 1. So 2 15 and you get 31. Then let's go to the last one. Now, what does this mean? You have to square the previous number. That means if I'm here, you have to multiply 1 square, okay? And then you add 1 plus 1 square is 1 plus 1 is 2. Then you do 2 square. 2 square is 4 plus 1 is 5. Then 5 times 5, that means 5 square plus 1, which is 26. And then again, 26 square you multiply. Uh, did I make a mistake? Okay, and yeah, and then that answer you get is 667. You can check this. I think I have it 677. So check that. The last one is, what does this mean? Is the F and the previous one, that means if this is the win, and double the step number and take away 2. Let's see what that means is the step number. Suppose this is 2. Okay. So if I want to figure out this part, you have to, is this one, let's say 1 plus, then it is 2 times. That means it is 2 times this n. N is 2, the pink one. And then, and subtract 2. So subtract 2. So you work this out, this becomes 5 minus 2. So your answer becomes 3 here. And again, now what you do is it is 3 plus double the step number. So now it is 3. So double. So it is 2 times 3, and then you take away 2. So this becomes 6. 6 plus 3 is 9, and you get 9 minus 2 is 7. So you get this is 7 here. So let me wipe this out. We get. So this is 6, 9, 7. Then again you multiply 7. So it is the 7 plus, you double the step number, which you double is now it is 4, and you take away 2. So this becomes 4 to the 8 plus 7 is 15, take away 2 is 13. So, and the next one again. Let's do the next one. Question number 5 is a sequence has F1. So they did give us the very first term. That means, let me build up this 1, 2, 3, 4. And if this is a step number and this is f of n, right? So they gave you f of 1. That means the very first term is 120. That's 120. And the next one is 60. Now, question is, you need to figure out two terms, the next two terms, if it is arithmetic sequence. Now, what is arithmetic sequence? Is there is a rate of change. So how much it goes down? So it is going in decreasing by 60. So from 120, it reduces to 60. So how much is less? 60 take it's like 60 minus 120 is minus 60. So going down by 60. And likewise, we can go minus 60 minus 60 will be 0, and 0 minus 60 will be. So this is how you're supposed to find out. So that's minus 60 right here. So I hope that takes care. But if it is the geometric sequence, that means this time you want to say if it's geometric 1, 2, and 3, and 4, and this is 120 and 60, this is n, and f of n. So that means what is the growth factor? Remember, this is the rate of change, which is also called the common difference. So I want you to guys get that d is minus 60 here. Okay, now in this example, we need to know what multiplies to 120 to get 60. The best way is to do 60 divided by 120. And if you see it's a half, so that means you're multiplying half to 120 to get that 60. Again, you multiply half, you get 30. And again, you multiply half, you get 15. And that's all they're asking you. So you're supposed to say, write down this is half. And this is because it's ratio, we call it common ratio, and also it's also called growth rate. So later on we'll see what is the meaning of that growth rate. Means it can be either it can increase or decrease, so doesn't mean growth means growing. So here it is going down. So what percent is going down? We want to say what is that half basically means in terms of 1 minus half. So we are going to check that it's like 100%, you take away 50% kind of thing. So it decreases by 50%. See, that's how it is. So the growth, the later on we'll see growth factor or growth percentage. So we'll see growth rate, there will be growth rate. So this is growth factor R, and the growth rate will be like a 50% kind of thing going down by 50%. So every time what stays is 50%. So that we'll see it later on. Let's go to the. Okay, this is the last problem of the lesson. So, an hour after the antibiotic is administered, a bacteria population. So, in the beginning, the population is given. See, the first is 1. That's when the number of hours. When 1 hour has passed, the bacteria population is 1 million, and each hour it decreases by a factor of half. So, based on that means in 2 hours, half of that will be 500, right? 500 million, and again it will be 250 million, and again you take a one, and then so on. So the question is asking you complete the table with the bacteria population at the given times. So from the time the uh, antibiotic is being administered, you're supposed to figure out what's going on every hour, right? So that's all the question is. 2 hours, 3 hours, and this is a geometric sequence. Clearly this is a geometric sequence because there is a there is a growth factor. So, or there is a common ratio. So every time that R is, in this case, the R is half. That's all it is. So, and we will continue this in lesson number 7. So lesson number 7 is more of writing the nth term, right? This is the main thing which I already did in my previous video, but I'm going to show like how do we get for arithmetic sequence, like any term is always the first term, the very beginning, and then it's always the rate of change n minus 1. And also for geometric sequence, let's say g of n, it will be always the very first term, and then you multiply the common ratio r and n minus 1. So that's what we are going to see. And this is for n greater than 1, this is n greater than or equal to 1. So thank you for watching, and I hope you guys will complete lesson 5 and 6 practice problem in the same package. So you have two different videos, and this one and then